Precalculus Mid's first 6 weeks test, 2015. We had 14 problems on this test. I'm going to go over all of them as a review. First one, a lot of people have trouble with: how many discontinuities can be found in the following function? Well, for discontinuities, one place we can look is the denominator. Why is the denominator a key place to look? Because we cannot do what? We cannot divide by 0 in math or in algebra, right? So, on these problems, I'm going to try to work these out algebraically first, and then look for confirmation with the TI-Inspire CX graphic calculator. Anyway, we see x's down here in 3 places. Here we have this x, we got this x, we got this x. How many x's do we see? We see 1, 2, 3. Our first instinct should be that there are probably 3 discontinuities here. Indeed, if we have x equals 0, that's where one discontinuity occurs. We have x minus 2 equals 0, which means x cannot equal 2. X cannot equal 0. And x plus 3 cannot equal 0. So x cannot equal to -3. So we have 3 zeros, and if we write this in interval notation, we go -infinity, comma, our lowest thing, -3, union, -3, comma, 0 is our next discontinuity, union, 0, comma, 2, union, 2, comma, infinity. That's our, we have 3 discontinuities here. We have this one here at -3, we have this one here at x equals 0, and this one here at x equals 2. Anyway, graphical confirmation. Okay, we go to our graphing calculator, we plug in, we go to get a graph here. You should have already answered this and not have to go to the graphing calculator, but in case you do, we go ahead and put in this. We put in x squared over x times, we have x minus 2 quantity times quantity x plus 3, and graph. We see, now if you just graph the thing, you might see 2 discontinuities here, because the one in the middle is a removable discontinuity, this one at 0. But if we go to table view, Control T, we look and we see we'll go up here, at -3, this pound UN, undefined. At 0, pound UNDE, undefined. And finally, at x equals 2, undefined. Should have been an easy problem. All right. So we go ahead and original confirmation. Yes, C is our correct answer. Next, 2. Which type of discontinuity will be not likely seen when graphed using the graphing calculator? Well, that's going to be your point discontinuity, which also can be called your removable discontinuity. Discontinuity or whole. That's number 2. Number 3, for the function fx equals x to the 4th minus 7x squared plus 6x, what are the approximate coordinates of one of the local minima? And so we go to the calculator here again. Okay, Control I. We add graph, and we enter x to the power 4, and we have minus 7x squared plus 6x And really, this is a graphing calculator problem. I guess there are other ways you could look at it using non-calculus methods. Anyway, we have two local minima. We got one down below here. We cannot see. I'm going to adjust the window just so we can see that one. Window settings. I think if we go down to negative 20, y minimum negative 25, we should be able to see that, or negative 20. I hope we see it there. Okay. Almost. You can almost see it. Let me do it just a little farther. 4. Window settings. Okay. Okay, we got two local minima here. We got this one way down here towards negative, looks like negative 24, something like that. We got this one up here. And we can find what they are by going to menu. You can trace also. I like to use analyze graph. We have a minimum 2. We'll pick this one on the right. I think that's right. We have left, right. So this is our minimum here. 1.6, negative 1.77. 1.6 comma negative 1.77. Okay. Well, it's going to be this one. We don't have anything around negative 26, right? So this would be 1.6, negative 1.77. We're very close, round off to 1 decimal place here. So A is our correct answer. 4, over what interval is the function decreasing? Now we look over what x interval. Well, we see that from negative infinity, the function is increasing all the way up, all the way up, all the way up, until we get about here. Okay? So there's where the function stops increasing. And then the function is decreasing all the way down to about here. Okay? So there we are on the x-axis. This interval that I'm bracketing here is where the function is decreasing. And if we look at our answers, our function is decreasing from about x equals 2 to x equals 7. So our correct answer is D. On to problem 5. Which graph shows a piecewise function? A piecewise function is a function that's composed of more than one piece. Okay? Piecewise function. Okay, function, let's say, of more than one piece. One piece. All right, now, if you look at C looks like it could be more than one piece, but B is definitely more than one piece. C could be like some transformation of an absolute value function, but B is our correct answer. Should be very easy. All right, problem 6. Find the values that are excluded from the domain of the function, or restricted from the domain. We don't have any restrictions due to what's in the numerator, but in the denominator. That's what we're looking at. Okay, specifically, we know that 4x squared plus 8x cannot equal what? 0. And if we take a greatest common factor from these two terms, that's going to be 4x times x, and so 4x times x equals 4x squared. 4x times what equals 8x? Well, that's going to be plus 2. It's not equal to 0. So we know 4x cannot equal 0, and we know that x plus 2 cannot equal 0, and so x cannot equal 0, x cannot equal negative 2. And so our correct answer is going to be B. And if we graph this in our graphing calculator, we should get ample evidence or some evidence of this. Okay. There we go. Add graph. We have x squared in the numerator. In the denominator we have 4x squared plus 8x. To graph this, we see one discontinuity at -2, and that should already give us our answers. The only, well, actually could be B or C based on that. If we go to our Control T, we see our second discontinuity at x equals 0. See that? Undefined, and at -2, of course. So, accordingly, our correct answer is B. Next problem, 7. What is the domain of the function in interval notation? And first of all, D is not correct because D is not an interval notation. So that elimination becomes easy. We can solve this algebraically. We know that x minus 6 inside the radical here has to be greater than or equal to 0. So x has to be, if we add 6, greater than or equal to 6. Well, all this stuff, like B has stuff that's less than 6. C has stuff that's less than 6. A is our only possible correct answer. And this thing in the bottom here, we know that x squared minus 16 cannot equal 0, right? If we add 16, x squared cannot equal, what is that? 16. So x cannot equal plus or minus 4, right? Take the square root. But that's all not necessary because of what this takes care of in the numerator. And finally, to graph this thing, when we graph this thing, let's take a look at this. We go to control, we get square root of x minus 6, and down below here we have x squared minus 16, and we graph this. We really can't see it. We can see right here at 6. We don't see anything less than 6. You can see maybe just starting at 6, this lavender line. And then if we go to the table view, Control I, oops, what am I doing here? Escape. Let me go back here. Control T, here we go. All right, see error, up until x equals 6. Okay, there should have been an easy problem, easy. Okay. What values are restricted from the domain of the following function? Well, we cannot divide by 0, so we should know that this x here is a problem for us. So x cannot equal 0. That is restricted from the domain. Should be easy. I'm not even going to graph the thing. Now, 9. What is the quotient of the quadratic trinomial x squared minus 3x minus 70 divided by the binomial x minus 10? That means that one of these answers here, one of these 4 answers here that I'm just circling in, times this divisor is going to be equal to x squared minus 3x minus 70. So we'll just set that up. If we take x squared minus 3x minus 70, and we divide that by x squared minus 10. Well, what do we have here, our last term? We're going to have as our last term this thing right here, negative 70 divided by 10, by negative 10. What's negative 70 divided by negative 10? 7. So based on that, D is our only possible correct answer. And if we just multiply these back together, our quotient, which we call x plus 7 times our divisor, x minus 10, we should get x squared, 7x, 10x, and minus 70. Okay, we are going to have, that's minus 10x, we should have here negative 3x minus 70. 10. What is the domain of the following function? Well, we cannot divide by 0, so we have x cannot be 0. We have x minus 3 cannot be 0. So x cannot equal 3. So our only possibility is, like we have this on the number line, we have 0 and 3. We have open points there at 0 and 3, less than 0, between 0 and 3, and greater than 3. All right, what is that going to be? That's going to be answer D. Yeah, B is kind of a trick here if you're not careful about that minus 3 thing. And then if you graph this, you're going to see two. Let's graph this thing. Here we have we have 1 over x and we have plus 5 over x minus 3. See, we have a discontinuity at 0. That's a vertical asymptote. And also at 5. Go to the table view. Control T. We see at 3 we have a discontinuity. And at x equals 0 we have a discontinuity. So 2 discontinuities. And they are located at x equals 0 and x equals 3. Number 11, what are the binomial factors of the quadratic trinomial 12y squared minus y minus 20? Well, you're going to have factors of negative 20 first of all. So 4 times negative 5 is negative 20. That's a possibility. This second one, choice B, negative 4 times negative 5, that's positive 20, not going to work. Answer C, 4 times 5, positive 20, not going to work. So it's just between these two, A and D. So I think answer D is the correct answer. Let's verify that. Okay, we put the factors here, 3y minus 4 and 4y plus 5. So we have 12y squared, that's easy. We have 4y times negative 4 is negative 16y. And down here in the lower left we have 5 times 3y plus 15y, and then we have negative 20. Well, 15y minus 16y is negative y, so this is going to be D, our correct answer. All right, what is the domain of the following function? Okay, we have in the radical 5 minus x. So how do we make this? We cannot have that be negative, so 5 minus x has to be greater than or equal to 0. And if we subtract 5, we have negative x is greater than or equal to negative 5. And if we multiply this equation, this inequality, by negative 1, we get x, and we change the direction of our inequality. X is less than or equal to 5. And so that is going to be found right here in answer B. Then if you graph this function, which I'm not going to do, but you have, it looks like this, 1, 2, 3, 4, 5. You have a backwards looking square root function, looks like this, which confirms answer B. 13, what are the factors of trinomial x squared plus 9x plus 18? Everything is positive in here in this quadratic trinomial, so anything with a negative number in it is wrong. So D is wrong. B is wrong. It's going to be between C and A. Well, I think A is the correct answer because if you take these factors, x plus 3 and x plus 6, you get x squared plus 3x plus 6x plus 18, and 3x plus 6x add up to 9x. So that will be your correct answer, A. All right, problem 14, the last one. On the grid provided, sketch as accurately as possible the following function. You have f of x equals x cubed minus 4x over x. Well, let's do that. Okay. We have x cubed minus 4x over x. Minus 4x over x. All right, so this just looks like a quadratic function, right? And the y-intercept here is down at -4, which makes sense. So when we sketch this, let's go sketch it. We have our marked y-intercept down here, at -4. And I was looking for not a perfect sketch, but just generally, if you came anywhere, your y-intercept was anywhere -4, that was okay. That isn't the problem I saw in this one. So the sketch is going to look something like this. Okay. But the problem is not what I've just sketched here. You guys who drew that in, most of you did a tolerable job of this. But here's where the problem is. You have a discontinuity, so x cannot equal 0. And what there is a removable discontinuity at x equals 0. And so to do that, how did I say you did that? You go ahead and you draw an open point right here. And what I was looking for is a visible open point at x equals 0. Right here. That is going to be your hole or point discontinuity. All right, if you look back at the earlier problem in the test, says, in fact, it was problem 2, which type of discontinuity will be not likely seen when graphed using a graphing calculator? So we do not see this when graphed, right? We do not see that point discontinuity. And so for full credit, I'm looking for that hole right there. And another way you can tell there's a hole is if you take your calculator, and like we're back to our calculator view, when we go to table view, Control T, what do we see at x equals 0? Undefined. So we got to draw in that hole for full credit on this problem. So good luck. Study this. We're going to have our semester final is going to have a lot of problems like this, and if you want to take a retake of this test, come and talk to me about it. Good luck to you, and thanks for viewing.